Hello. In today's lab, there will be lots of configurations to do. I hope my videos are helpful for those who are seeking to be certified for Cisco exams. If you like my videos, please click on the subscribe to my channel and recommend it to your friends. And share it on your Facebook, and please give me the thumb up. And please let me know if you have any suggestions, comments, or questions. I will gladly answer you back. On the description of this video, you will have two files, one for the packet tracer source files and the documents to walk you through the lab step by step until you finally will be able to verify the configurations you did during this lab. Now I will start doing the configuration on the interfaces. I'll start on router 1. Enable configure terminal. I'll give it the host name here, router 1. And next I will enable IPv6 routing because we'll use IP version 4 and IP version 6 on the interfaces for this lab. Now IP version 6 Unicast routing, just simply like this. Now on the interface of gig 00, the IP version 4 address of 192.168.10.1/24 subnet mask, and on the same interface for IP version 6 address of 2001 DB8 ABCD 1::1/64. And here I will enable the interface with a no shut. On the other interface of serial 00, the IP version 4 address of 10.1.1.1/30 subnet mask, and the IP version 6 address of 2001 DB8 ABCD A::1/64. And once again here also I'll enable the port, the interface with a no shut command. Now let's move to router 2 here. We have this interface on serial 00, and this interface, this is what I'll be configuring for now, and as for this, I'll do this later. Router, enable, configure terminal, and the host name for this interface of router 2. And also here I'll enable Unicast IP version 6 Unicast routing. On the interface of serial 00, the IP version 4 address of 10.1.1.2/30 subnet mask, and the IP version 6 address for this interface DB8 ABCD A::2/64, and also I will activate the port with a no shut. So now the other interface serial 00, interface of serial 001, the one facing router 3, IP address of 10.2.2.1/30 subnet mask, and IP version 6 2001 DB8 ABCD B::1/64, and activate the port with a no shut. Now I'll move to router 3. I'll configure the two interfaces, the serial 001 facing router 2 and this interface for this LAN here on the gig 00. Enable, configure terminal, host name, router 3. On the interface of serial 001, the IP version 4 address of 10.2.2.2/30 subnet mask, IP version 6 address of 2001 D8 ABCD PPP:/64. And also I'll activate the port with a no shut. The other interface on gig 0 gigabit Ethernet 00 IP address of 192.168.30.1/24 subnet mask and IP version 6 BB8 ABCD 3::1/64 and enable the port with a no shut command. Next, I will be configuring point-to-point protocol between router 1 and router 2. Now, what does PPP stand for? It stands for point-to-point protocol, and it's a data link layer 2 communications protocol between two routers directly without any host or any other networking in between. It can provide connection, authentication, transmission, encryption, and compression. Now, Chap, C-H-A-P, short for Challenge Handshake Authentication Protocol, a type of authentication in which the authentication agent, typically a network server, sends the client program a random value that is used only once and an ID value. Now, what is PAP and Chap in networking? Password Authentication Protocol, which is PAP, stands for PAP, and Challenge Handshake Authentication Protocol, CHAP, are both used to authenticate point-to-point protocol sessions and can be used with many VPNs. Basically, PAP works like a standard login procedure. The remote system authenticates itself to the using a static username and password combination. Now, I will set encapsulation to PPP and configure CHAP authentication. Then I will create a local database entry for CHAP authentication. Now, the user name on router 1, I'll use router 2 as a username and the password of Cisco. So here on router 1, in the global configuration, now on the interface of serial 000, the one facing router 2, encapsulation PPP. Now, PPP authentication, we will use Chap. I'll exit from here. Now, the username on router 1, I'll use router 2 with the password of Cisco. Now I'll do router 2. I will set encapsulation to PPP and configure Chap authentication. Then I'll create local database entry for Chap authentication. Now on router 2, the username will be router 1 and the password of Cisco. So from the global configuration, conf-t, configure terminal. Now on the interface serial 000, the interface facing router 1, encapsulation PPP. For encapsulation, we'll use PPP. Now, for the PPP, we will use the authentication of Chap. I'll exit from here. And for the username is router 1 and password of Cisco. Next, I will configure IP routing on router 1, router 2, and router 3. On router 1, I will configure a default route. I will use the interface of serial 00 as the exit interface. Here on router 1, IP route to any network with this subnet mask and the exit interface or the gateway, default gateway of serial 000. Now I will enable EIGRP for IP version 6 routing. Now, the command goes like this: IP version 6 router EIGRP and the autonomous system or number of 1. Now the EIGRP router ID on router 1 of 1.1.1.1. No shut. Now I'll configure the interface. The interface of gig 00, the LAN on router 1, IP version 6, EIGRP 1, and the other interface facing router 2, IP version 6, EIGRP Autonomous System 1. So we are done configuring EIGRP, the routing protocol on router 1. Now let's move to router 2. On router 2, I will not configure any default route. But on router 2, I'll configure only EIGRP. From the global configuration, IP version 6, router EIGRP with the autonomous system number 1. EIGRP router ID on router 2 of 2.2.2.2. No shut. And then I'll exit from here. I will configure the two interfaces of serial 000 IP version 6 EIGRP 1 and the other interface of serial 001 IP version 6 EIGRP 1. Now as you can see here, we have the neighbor on the serial of serial 00 is up, a new adjacency between router 2 and router 1. So now I will be configuring EIGRP on router 3. First, I will configure a default route and use this interface here on serial 000, serial 001, sorry, as the exit interface. So IP route, IP version 4 route to any network with this subnet mask and the exit interface on serial 001. Now, IP version 6 router EIGRP with autonomous system number 1. But first it's telling us here that IP version 6 routing not enabled. So what I'll do is IP version 6 Unicast routing. I'll do the command again, IP version 6 router EIGRP 1. Now EIGRP router ID on router 3 of 3.3.3.3. No shut. I'll exit from here and now to configure both interfaces, serial 001, IP version 6 EIGRP with autonomous system 1, and the other interface, the LAN on router 3 on gig 00, gigabit Ethernet 00, IP version 6 EIGRP with autonomous system number 1. Now let's check if we can ping router 3 from router 1 after we did this configuration. So I'll ping here, ping 10.2.2.2, and we can. And from router 3, I want to ping this interface here, ping 10.1.1.1, and sure we can. Now let's see if we can ping the IPv6 interface from router 3 here. Ping 2001 DB8 ABCD A : 1, and sure we can. Next, GRE tunnel. The GRE tunnel developed by Cisco Systems, Generic Routing Encapsulation. This is what GRE stands for, Generic Routing Encapsulation, is a tunneling protocol that makes it possible to encapsulate over an Internet Protocol network a large variety of network layer protocols inside virtual point-to-point links. Now I will configure BGP between router 1 and router 3. Now on router 1, here I will use interface tunnel 0 and set the tunnel source. This will be the tunnel source here on the serial 000, and set the tunnel destination on router 3, this interface here on serial 001 address, and create a host route to the tunnel destination using mask /32 255.255.255.255, and use interface serial 000, this interface here. So now on router 1, from the global configuration, configure terminal, the interface of tunnel 0. Now the IP address here we are using of 192.168.1.1, which is this IP address here for the tunnel, and with subnet mask of 30.255.255.255.252. The tunnel source on the interface of serial 000, tunnel source serial 000, which is this interface here for router 1, this interface. And the destination will be the address on this interface. And here, tunnel destination, and that IP address of 10.2.2.2, and hit enter. Now I'll exit from here. Now I'll create a host route to the tunnel destination. So the command goes like this: IP route to 10.2.2.2. This interface itself, and this will be with /32 subnet mask 255.255.255.255, and the exit interface will be here, this interface on serial 000. Next, I will configure BGP. BGP stands for Border Gateway Protocol. It is a routing protocol used to transfer data and information between different host gateways, the internet, or autonomous systems. BGP is a path vector protocol, PPP, which maintains paths to different hosts, networks, and gateway routers, and determines the routing decisions based on that. So now we're still on router 1. Command goes like this: router BGP, the autonomous system here of 65010, 65,010, enter. Now the neighbor for the BGP here would be this interface of 192.168.1.2, and this interface, or this neighbor with a remote autonomous system, as you can see here, of 65030. 65030, and then hit enter. Now I will advertise router 1 LAN. We will advertise this LAN here. Network of 192.168.10.0, and this is with a mask of /24 255.255.255.0, and then hit enter. Now I'll do the same exact thing here on router 3. I will use interface tunnel 0, set the tunnel source to serial 001 here on router 3 from the global configuration, conf T. Now the interface of tunnel 0. The IP address here for the tunnel of 192.168.1.2, and this is with /30 subnet mask. Now the source is this interface of serial 001, serial 001, and the tunnel destination will be this interface IP address of 10.1.1.1, this interface on router 1 here on serial 000. and then hit enter. I'll exit from here. Now I will create a host route to the tunnel destination from router 3 to this guy here on 10.1.1.1. IP route 10.1.1.1, and this is with /32, 255, 255, 255, 255. And the exit interface from router 3, it would be this interface on serial 001. 001. Hit enter. Next, I will configure BGP on router 3, just like what we did in router 1. Router BGP, and this is with autonomous system, as you can see here, of 65030. 65030. Now, the neighbor is 192.168.1.1. And this neighbor here on this interface, this is with the remote autonomous system of 65010. Next, I will advertise the LAN here on router 3. The network of 192.168.30.0, and this is with the mask of /24.0. Now let's check connectivity, see what we did so far. On router 1, I will ping router 3. In router 1, let's see, ping 192.168.1.2, and it was successful. And on router 3, I want to ping router 1, ping 192.168.1.1, which is this interface of the tunnel. From router 3, it will go through here. Now, while I'm at router 3, I'll run this command, show IP route. Here, can you see from, this is the BGP. It can reach this network, the LAN on router 1, via the tunnel. Next, and while you are here, practice to run whatever show command you can think of just to see what you did so far. Now let's see if we can ping from PCA here to PCB. So desktop command prompt ping 192.168.30.10. And yes, we can. We can ping from here all the way to this, from PCA to PCB. Let me see if we can ping from PCB to PCA. Ping 192.168.10.10. And yes, we can. Next, I will configure a point-to-point protocol over Ethernet. Now, what is PPPoE? It's a specification for connecting multiple computer users on an Ethernet local area network to a remote site through common customer premises equipment, which is the telephone company's term for a modem and similar devices. Now, what is PPP over Ethernet and how does it work? Point-to-point protocol over Ethernet combines PPP, which typically runs over broadband connections, with the Ethernet link layer protocol that allows users to connect to a network of hosts over a bridge or access concentrator. Now, on router 2, here, And before I go with this, there are some commands are not supported by packet tracer, but I will show you how we type this command if you will use a different, maybe GNS3 to run this lab. So on router 2, enable from the global configuration mode. I will configure a username. I'll call it user1 with the password of CCNA. Username, user1, password CCNA. Now I configure the local pool, which I'll call it pool, caps, and then set a range of IP addresses from 8.8.8.1 to 8.8.8.10. So IP local pool, which I said I call it pool, from 8.8.8.1 to 8.8.8.10. This is the pool of addresses. Now I will configure interface virtual template 1. Now the interface of the virtual template, I'll give this interface number 1. Now I will set an IP address for this virtual template of 8.8.8.254 with a subnet mask of 255.255.255.0. But this is not supported with packet tracer, but I'll show you how it is done. IP address of 8.8.8.254, and this is with a subnet mask of 255.255.255.0. This is the IP address of the template. But when I hit enter, it will show me that this is not supported by packet tracer. But the alternate here, IP unnumbered, this is for this interface on router 2, which is gig 00. Now, we need to set the MTU, which is the maximum transmission unit, but also this is not supported by packet tracer. Now, what is the MTU? Maximum transmission unit is the largest packet or frame size specified in octets, 8-bit bytes, that can be sent in a packet or frame-based network such as the Internet. The Internet's Transmission Control Protocol, TCP, uses the MTU to determine the maximum size of each packet in any transmission. So usually the command will go like this here, packet MTU, and then you will give the number of 1492, but it is not supported with the packet tracer. Now I will set the peer to use a default IP address from the pool. The interface of virtual template, interface of the virtual template 1. Here the peer default IP address pool, and we called it pool, PPPoE. Enter. Now I will set the authentication chap, I'll call it colon, PPP authentication, chap, colon. And here is giving us a warning. Now I'll exit from here. I'll be exiting the virtual template interface because we are configuring the interface. Now I will configure BBA group, and BBA stands for Broadband Aggregation Group. BBA group, PPPoE global, and then enter. Now we are enabling point-to-point protocol over Ethernet global using virtual template 1. Now, virtual template 1, we did this configuration for virtual template 1. I'll exit from here. Now I will enable PPPoE over the physical interface gig 00 on router 2, which is this side here, the one we said we will configure later. Now, on the interface of gig 00, PPPoE enable group global. Now activate the interface gig 00 with a no shut command. Now we are done here with router 2, so let's work on the configuration on router 3. I will configure the interface, this interface on router 3 gig 01. So to obtain an IP address from router 2, configure terminal on the interface of gig 01, PPP over Ethernet, enable. So we enabled it there, PPP over Ethernet client, and here dial pool number 1, enter, and activate it with the no shut. And I'll exit from here. Now I will configure the dialer interface 1. I will create the virtual dialer 1 interface. Now, from the global configuration of router 3, interface dialer 1, enter. Now I will negotiate the IP address from router 2. IP address negotiated from router 2, which is here, router 3, interface of gig 01, which is the client, and router 2, which is the server. IP address negotiated, and hit enter. Now I will reduce the MTU to 1492 to accommodate the point-to-point protocol headers. So the MTU of 1492, and then hit enter. Now this is for the encapsulation USB point-to-point protocol. Now I will create dialer pool 1. Dialer pool 1, enter. Then I will enforce and assign the Chap authentication. Point-to-point protocol authentication, Chap colon. The username, which we use user1 with the password of CCNA. Point-to-point protocol, Chap. Host name, user1. Point-to-point protocol, Chap. Password of CCNA. Enter. Finally, I will activate the physical interface, this physical interface on router 3. No shutdown. Exit. Now I will configure a static default route using the dialer 1 as the exit interface. Now from router 3 to router 1. IP route to any network with this subnet mask, and we'll use the dialer 1 as the exit interface, and then hit enter. Now, this is how you configure point-to-point protocol over Ethernet. And as I said, If you use GNS3, this is the commands you need to use to do this lab or this configuration. And Packet Tracer is not supporting all these commands, but if you follow the walkthrough documents at the end of in the description of this lab, this is how you do it if you will use GNS3. Next, here I will run this command here when we are done. Exit, show IP interface brief. As you can see here on router 3, this is for our tunnel 0. This is what we configured. And this is for the dialer, and it is IPCP is up and up. And this is for the virtual access 1. This is for the virtual access 2. And you will have more configurations to show in the show command if you are using GNS3. But this is to demonstrate it and make it easier for you. This is how it is done. Next, I will configure IP access control list on router 1 and router 3. I will configure an IP version 4 extended access control list on router 1, and I will name it ICMP, and deny all pings to router 1 LAN. Now, what is an extended access list? Extended access control list, ACL, allows you to permit or deny traffic from specific IP addresses to a specific destination IP address and port. It also allows you to specify different types of traffic such as ICMP, TCP, UDP, etc. So now here on router 1, enable, configure terminal, IP access list, use it extended, and as I said, I will name it ICMP, enter. Now I will deny ICMP from any network to any taker, but I will permit any IP protocol from any. Next, I will place the access control list at the correct interface and destination. So I'll exit from here, and now on the interface of gig 00 on router 1, because we will deny ICMP to this LAN, so we will place it on this interface. Enter. Now, IP access group, we call it ICMP, and on the outbound, out. Enter. So we are denying any ICMP to this LAN here from any destination, from any network. Now on router 3, I will configure an IP version 6 extended access list named access and deny all pings to network router 3 IP version 6 LAN. So here on router 3, configure terminal, IP version 6, access list, I will call this access, enter. Now I'll deny ICMP from any to the LAN on router 3, which is of 2001 DB8 ABCD colon 3 colon to this network, to this LAN on router 3. Echo request, enter. But I will permit any IP version 6 from any to this LAN. Sorry, permit IP version 6, any. Now, I will place the access control list at the correct interface and destination. So we will deny any ICMP to this LAN here on router 3. So I'll exit from here, interface gig 00, IP version 6, traffic filter, and the access control list, which we called it or named it access, the outbound out. Now let's check connectivity between PCs. Now here I will ping the IP version 4 of PCB here. Ping 192.168.30.10, and we can ping it, but let's see if we can ping the IP version 6, DB8 ABCD 3::10, and it's saying unreachable. So we can ping it with IP version 4, but not IP version 6 as we. And now from PCB, we can ping the IP version 6 IP address for PCA, but not the IP version 4. So let's give it a try here. See if we now ping 2001 DB8 ABCD 1::10. Yes, we can. But we denied IP version 4 to be able to ping. Ping 192.168.10.10, and it is unreachable. So our work is perfect so far. Now I will be configuring SNMP version 3. But unfortunately, also, I'll give you an idea how you do this configuration, but it's not supported with packet tracer here. So what does SNMP stand for? It stands for Simple Network Management Protocol. SNMP is a set of protocols for network management and monitoring. These protocols are supported by many typical network devices such as routers, hubs, bridges, switches, servers, workstations, printers, modem, racks, and other network components and devices. Excuse me. Now, what is SNMP version 3 used for? Uses HMAC SHA-2 authentication protocol for the user-based security model, USM. A challenge response handshake was not used to improve security. SNMP version 3, like other SNMP protocol versions, is a stateless protocol, and it has been designed with minimal amount of interactions between the agent and the manager. Now, I will type the commands, but just to give you an idea, but as I said, it's not supported on packet tracer, but on GNS3 it is supported. So on router 1, I will create a standard access list to permit only LAN containing PCA, only this here. And I will name this access list SNMP. So on router 1, from the global configuration mode, IP access list, standard, I'll name it SNMP. We will permit only the LAN of 192.168.10.0 with the inverse subnet mask of 0.0.0.255. Enter. Now, by using the SNMP server command, I will configure SNMP if you include a specified MIP, SNMP view, which will be SNMP read-only RO, and the MIP include ISO. So MIP is a management information base, is a database used for managing the entities in a communication network, most often associated with Simple Network Management Protocol, SNMP. The term is also used more generically in contexts such as in OSI, ISO network management model. Now, what's the purpose of MIB or MIB? A management information base, MIB, is a hierarchical virtual database of network or other entity objects describing a device being monitored by a network management system, NMS. A MIB is used by Simple Network Management Protocol, SNMP, and Remote Monitoring 1, RMON 1. Now here, I'll type SNMP server view SNMP RO read-only ISO included. But unfortunately, this command is not supported by packet tracer, but this is how you type this command. Now I will use the SNMP server group command. I'm supposed to exit from here and SNMP server and type it like here. It will give us community when I type in the question mark, but in the real, if you're using a real router, it is using the view command and then SNMP read only RO and ISO included. And this is not, as I said, supported from the view here, but before this you will use community with packet tracer, and with the GNS3 it will give you the full command. Now I will use SNMP server group command. I will configure SNMP group, SNMP version with authentication and encryption, and limit access using an access control list. So the group is SNMP, and we'll be using version 3. Authentication and encryption, this will be required. And the access read only by using access control list SNMP. So the command goes like this: SNMP server for the group, SNMP version 3 privilege read SNMP read only access SNMP. And this is how you will use the command and hit enter. But as I said, it's not supported by packet tracer. Now, or finally, I'll create the user. This is how to create the user and set the authentication and the password. This is allowed by just if you type SNMP and then hit the tab, it will give you SNMP server, but after that it is not supported. But the command goes like this: SNMP user, we'll call the user here admin, SNMP version 3, use the authentication, SHA, and the user admin 1 privilege, PRI privilege, AES 128, 128 bits, and for the user admin 2. This is how you type the command. Very simple when using SNMP version 3, and then hit enter. But as I said, this is not supported by packet tracer. Hopefully, if you are using packet tracer, this is how you do the command. And then after you are done, just run some show commands and see how you did so far. This is in a very simple way how to configure SNMP version 3. Thank you so much for watching. And if you have any comments, suggestions, please, you know how to reach me, either by a message or comment. And please subscribe to my channel by hitting the subscribe button. And I'll see you soon in my next video. Have a nice day.